Okay. Okay, let's start. So, first let's pick up from where we left last time, okay? So, we were talking about the structural identity, which is kind of implicit identity, okay? And take a look at this one, this code, which is, again, is a computed variable, and it returns some view, okay? So do you think, is there any issue here? So whether they're actually gonna compile or not? Okay, so what's the problem here? If there's any, yep. Just go ahead, yeah.
Text and image are not the same type, so my view, type of my view is not defined.
Yeah, so yeah, exactly. When the compiler actually trying to infer the type of, to replace the sound view here, you kind of look inside your code block, okay, and you see two different things based on different conditions. So first is like, is a concrete type is a text, and the next thing is an image, okay? So you cannot actually infer the right type for this one, okay? And there are some solutions. So one of solution I provided before, which is in lecture 4.2, I believe, and you might already use that in your assignment, which is the view builder, okay? So take a look at this thing. So, well, you may be familiar with that. Just apply with the @ symbol and say view builder, okay? It kind of silence a warning, okay? And the view builder, this thing, @view builder, is actually something called function builder, okay? Just one of the function builder that Apple defines for you, okay? And you can, of course, you can also create your own function builder. But if we have time, we will talk about that later. And well, so what actually happened behind the scene? So when you apply a function builder here, okay, essentially just take the body of your function and do some like pre-processing, okay? Now, let's take a look at this thing. So when you apply view builder here, you can actually compile into another data structure, which calls something like, well, underscore conditional content, okay? So that's another data structure defining standard library, okay? And it basically looks like a tree structure, okay? And it can form or like organize the internal structure of this data structure based on your if statement, okay? So if you got like more if statement, like you say if else, or else, actually you're gonna contain 3 generic type here, okay? So this is 2 generic type. The first one is text, and the second one is image, okay? Now let's think about like why we call this, like how the Swift UI actually see the different identity for different views in this case, okay? Now let's take a look at this thing. As I mentioned before, the sound view gonna be replaced by another data structure called conditional content, okay? Now for the conditional content, so when the statement is true, okay, it will show the text. And inside this conditional content, you're gonna assign an ID for the text, okay? And for the image, if the condition is false, okay, you're gonna show the image, and also you have a unique identifier, okay, assigned to the image. Now, there are actually some other ways to fix that, try to silence the compiler. There's other ways. So one thing you can try is called type eraser, okay? So one famous type eraser here is something called AnyView, okay? Essentially just a wrapper class to wrap a view, okay? Why we call that as type eraser? Because when you wrap something inside this AnyView, type just becomes AnyView, okay? It doesn't contain any additional information about its concrete type inside that, okay? It's just AnyView. Kind of erase the type of its, erase the type for the value it wraps around, okay? Now, you can do something like that without using the view builder, okay? You have to explicit to say return keyword here if you don't use view builder, okay? And you have to put the AnyView to wrap both text and image. In this case, the type of two different branches in this if statement is gonna they both AnyView, okay? So in this case, the SumView gonna be replaced by a type called AnyView during the compilation, okay? Now, so what's the problem here? Can you think of any problem here? By using the type eraser here, by using the AnyView here. So it's about structural. Okay, so if you use the view builder, okay, it kind of form a class which called conditional content, and it contains lots of information about the details. Okay, and it has the identity for each child view inside this conditional content. Okay, so Swift UI gonna have lots of information to process. In this case, it can do lots of optimization, okay, behind the thing. And when you do when you apply a type eraser, in this case, Swift UI it still work, okay, but you have you're gonna have some trouble to do the optimization, and it's kind of related to performance issue, okay. So whenever it's possible, just use the view builder, okay. Try to avoid this thing. Try to avoid type eraser, okay. Now, let's talk about another thing. It's about stable or unstable identities, okay. So actually take a look at the code here. So this file called stable or unstable id.swift, okay. Now, first we define a kind of model, okay. It's named the stable ID demo struct, okay, and it conforms to identifiable in this case, and it has a property which is named as num, okay. It's an integer, okay, and to conform to the identifiable, we create a new thing. We create an ID, okay, and this is computed variable and return the UUID, okay. Every time it returns a new UUID. Is that clear for you guys? Because it's computed variable. When you access this one, you just create a new instance of the UUID. Okay, so it gets a new UUID. Okay. Now, this structure is kind of quite simple here. Now, take a look at this thing. This is our view model. Okay. In this view model, we declare an array of this struct, this model. Okay. And we mark that as published because we're gonna use that later. Okay, and we have two functions here. So first function is load data. Essentially, we just remove all the thing inside this array. Okay, and just append 5 items into that. Okay, and for each stable ID demo struct for each instance, it created with a different num variable, okay, so from 0 to 4, okay. And another function is called add1. It's essentially just add one additional the model to the array, okay. And we're gonna increase the number just one by one, okay. So when we call the add1, if let's assume we already have 5 items, 5 elements inside this my structs array, okay? So when we call the add one, we just add another element with the number as 6 and 7 and 8, okay? Now, let's take a look at this our view, okay? Right here, we declare a state object, okay? And we're gonna use the view model we just defined. And in this body, we use this thing. It's a new thing to you. It's called list. It's kind of like for each, okay? But it kind of applies some additional effects, like well, you can go to your iPhone settings page. You can see all this nice thing layout. Well, there are lists, okay? And well, the usage of this thing, this list, is kind of similar to the for each. Okay, passing a data in this case is an array. Okay, an array contains lots of different elements. Okay, and this one is refers to the individual elements inside this array. Okay, actually, what's going on with my preview? Anyway. Anyway, let's first take a look at this. The next thing is we apply an animation here. Okay, we say if the array, these my structs, this array, well, gets unchanged. Like maybe you add additional elements into that or remove one. Okay, it got animated. Okay, it's implicit animation here. Okay, and we have a button here to just call the add one. Okay, and this one, this unappear, we talked about that maybe last time. Yeah, it's kind of when the view appear on the screen. Okay, the Swift gonna execute the function, the codes inside this block. Okay, so when the view unappear, okay, we're gonna call the load data, essentially just created four elements inside this array. Okay, actually we need the preview here right now. Give me a second. Let's see. But like intuitively, okay, we got the preview here. All right. Take a look at this thing. Okay. So we have the button, which kind of reload data. It's not right one. It should be add one more data. Okay. Add the data. But anyway. So you can pay attention to the animation here. Okay. You can see something weird happen. Is that visible to you guys? All right. So just think about like one reason, like why would that happen in this case? Anyone? So I'm gonna show you one more time. You can see, well, Swift UI, well, have some trouble, you know, to figure out like what kind of animation you want to apply. Yep.
Do the like the IDs change corresponding to numbers that get reshuffled?
Yes, exactly. So in this case, just go to the top of this code. We can see how we define this ID. Okay. Each time when you access this ID, it creates a new instance of your ID. Okay. So each time when you refresh the data, not just refresh data, I mean you add one because it's just called the new ID. Okay. And it just generates a new ID, which is totally different than before. Okay. So in this case, you are going to have some trouble to trying to infer what kind of animation you want to apply, because well, all the view has a like total different IDs in this time. Okay, so it has some trouble to do the proper animation. So this ID, well, called unstable ID, because well, it's unstable. So in this case, we can just do something well really simple to fix this thing, to apply a stable ID. Well, we already have a number, and we know when we initialize this thing, the number is uniquely identified. Okay, so we can just return use this none. Okay, and you guys may not just realize that the ID can be anything actually. Okay, not really anything, but as long as it's something can be used to as some kind of identifier, okay, it's valid. Okay, what's going on? Now let's go back to the preview. Now, right now, when we access the ID, we just use the num, the local variable defined inside this struct. Okay, use the the noun. And the noun, when the struct is initialized, when you create an instance, okay, it's stable. Okay, it's 1 or 2 or 3. Okay, now let's take a look at this thing. When we add the data, you can see the animation, just it's fixed. Okay, now this case we usually call that as stable ID. Okay, I mean, in the real life, when you actually develop some app, you don't just do something like that. Well, it's kind of stupid here. Usually it refers to some ID, maybe stored in your database, okay? Some unique identifier which is stable in your database, and you're gonna use that ID, okay? Which is kind of more, it's a better choice, okay? Just trying to avoid the unstable ID, okay? Because you will have some trouble with the animation. Now, let's go back to today's topic, okay? So today we're gonna talk about optionals and error handling. So first thing is, well, just let me throw some concepts first. It can be a little bit confusing right now, but it's okay. So, well, there's something called optional, and where we need something called optional. So optional, well, it's a kind of official definition on the Apple's official document. It says a type that represents either a wrapped value or nil, the absence of a value. Okay. Anyway, let's go to the next one. So to have a optional, basically we have a way to express uncertainty. Okay. So which means the source we receive the variable value is not guaranteed to be credible. Maybe some case the value we get is kind of, well, you may see maybe in Python it's called none. Okay. In C++, you may call this no pointer, okay? Because, well, maybe sometimes we want to express a situation that the data doesn't actually exist, okay? So that kind of data, we need to check the data before we actually use that, because it might just contain nothing. Well, if you got, well, in C++, if you got a no pointer, you cannot use that, right? You have to do some additional error checking, okay? And optional is kind of a better choice over the no pointer in the C++ and none, well, in the Python. Okay. All right. So you already see lots of optionals in your assignments, I believe. So for example, here you may already apply several times to using the .frame view modifier, okay? And it takes two arguments. It can take two arguments. First is width, and second is height. And if you pay attention to the auto-completion the Xcode gives you, you can see the type of both variables is float with a question mark, okay? So whenever you see a type followed by a question mark, it means it's an optional, okay? So in this case, you can see float with a question mark. It's not float. It's not float, okay? It's an optional wrapped around float, okay? So, well, another example here is if you have a variable, simple variable, named as greeting, and the type annotation here is string with a question mark. So it's an optional string, okay? Now, this is, well, optional. So let's take a look at how compiler actually see your syntax here. So when you do this, well, when you do the type annotation, usually go the first way. You just say var greeting with type annotation with string with question mark, okay? But it's just a syntactic sugar, okay? During the compilation, the compiler actually gonna swap this thing to something called optional with angle bracket and has the string inside that, okay? So the optional here is just another it's just some data structure defined in a standard library, and we're gonna take a look at that. Okay, so any question here? Like the syntax? So the string here inside this angle bracket is generic type, okay? Yep.
So I didn't really understand, like, what is the advantage of using optional instead of just allowing to pass a null type?
Sorry, what?
What's the advantage of using this optional structure instead of having just the ability to pass a nil type into?
Just pass a nil, right?
Yeah.
Well, the thing is, nil actually is another syntactic sugar. It's also optional.
Oh, okay.
Yeah, yeah, we are look at that. Yeah, all right. So this is how optional actually defined in the standard library, in the Swift. Okay, and so are you guys familiar with that kind of syntax, like generic here, the enum? Is that all clear? Yeah. So the wrapped thing here is just a generic type. Okay, it's a label for a generic type. Okay, and you have two cases. First is some, which means that thing actually contains some data, and second case is none, means well, it doesn't have any meaningful data inside there. And the wrapped here is the associated data. If you recall from the previous lecture, we talk about when we talk about the enum thing. So each enum can have associated data, and this is associated data. Okay. Now, when you actually want to define a optional with some valid data inside that, you can do something like that. Okay. So first, start with var, which is a keyword, and the name of the variable, which is greeting, okay? And with the type of annotation as optional, angle bracket with string inside that. On the right-hand side of this assign symbol, we can declare a optional with optional.sum and put the string inside this parenthesis. Okay, this is how you define a optional in kind of the most verbose way, okay? Now let's take a look at some syntactic sugar to simplify this process when you declare some optional. The first thing is, well, when you provide a type annotation here, the Swift already know you're gonna provide a optional, okay? And in this case, if you put some string here, you already know you want to define a optional.sum. Okay, so you can get rid of the optional.sum here, just put a string. But again, it's not a string, it's an optional string. Okay? Now we can take a further step to get rid of this, well, the optional string thing. We just say string with a question mark. Okay, it's a syntax sugar I mentioned before. They are equivalent. Okay, all these three here, they are equivalent. Okay? Now, let's think about another case where we want to define a optional.none, means, well, the data actually doesn't exist. Well, at least when you see this line of code, the data doesn't exist. Okay? And you can see something like that. Okay? First thing, get rid of the optional angle bracket string. Just say optional, just say string with question mark. Okay? It means optional string. Okay. Now take a look at the right-hand side. We say optional.none. Well, that's actually a nil. Okay. So you have been using the nil, I believe, right? In your assignment, maybe. Well, actually, I showed that before. When you apply some height in the frame, you can say nil, which means, well, I give you the freedom to infer the height for me. Okay. Anyway, the nil actually is a syntactic sugar to replace the optional.none. So it's optional. It's not just a null pointer. They are totally different things. Okay, so it's optional. Now let's take a look at how we actually unwrap an optional. Okay, so what I mean by unwrapping an optional, it means how we actually use the data wrapped inside optional. Take a look at this example. So we have a variable named greeting, which is the optional string. But we have a, well, name. Again, it's a string instead of optional string. It's just a string. Okay. Now, that's, well, if we want to define a different string, let's say hello, and we're trying to like add these two strings together. Okay. Concatenate these two strings together. So, do you see any problem here? Or, well, I mean, just give a guess. Yeah, the greetings can be nil, okay? So the compiler gonna give you some warning, says, well, the value of optional type string with question mark must be unwrapped to a value of type string. Okay, because well, first thing is, well, there are two different type of thing. So first thing is optional, second one is just string. Okay, you cannot just, well, doing a plus sign on two different types. Okay, so now let's see how we actually extract the data inside this greeting optional thing. Okay, so we're gonna talk about four things. Okay, first technique is called optional binding. Okay, and we're gonna talk about optional chaining and new coalescing operator and unconditional unwrapping. Sorry, it should be unconditional unwrapping. But anyway, let's first take a look at the optional binding. And inside this optional binding, we're going to talk about like two different techniques. First one is this if-let unwrapping. So let's take a look at this function, this signature. We have a function named say, okay? Just say some greeting to somebody, okay? And inside this block, we can use the if-let keyword here, okay, to extract the data contained inside this greeting, which is a optional string. Okay, is that clear? So the else branch here means if the greeting here, the argument passed into this function is nil, or it means it's optional none. Okay, you're gonna fall back to this else statement. Okay, if it contains some valid data, okay, you're gonna grab the data out and assign the data to this greeting. Okay. Yep. Any question?
No.
All right, good. So in this case, this greeting here is a type of string. Okay, this greeting here is a string. It's not optional anymore. It grabs the data out of this optional string and put the string to that variable named as greeting. It can be any name you want. Okay, it doesn't have to be greeting. Okay, but usually you go this way because you can't avoid some confusion because well, just avoid creating lots of different names, which can be a little bit quite a trouble here.
So
But
if you call this say function and you don't provide a like greeting parameter for it, will the compiler complain?
so you mean like just put a name here without the?
Like if you don't provide a data like a parameter for greeting,
Uh-huh.
will the compiler?
No, compiler. Well, in this case, compiler still gonna give us an error because you don't have a default argument here. So the default argument is something different. It's something different. So you can put something like here with a sign symbol here. Say, well, the default value in this case is nil. In that case, you can just skip the parameter when you call this function. Okay.
So if it's nil, then it will return no valid greeting.
Yeah, so if you pass a nil into this one, well, you pass a nil as a greeting into this function, you're gonna just print no valid greeting text available here. Okay, if it has some data, okay, you're gonna just print, well, the greeting concatenated with the name. Okay. Now, another technique is called guard let. Okay. So by combining use the guard let, well, it's kind of similar to the if let. Again, you bind the data, the valid data inside this greeting optional to the greeting. In this case, greeting again is a string. Okay, the greeting on the left is a string. Okay, but the greeting on the right is optional. Okay, and the guard actually is kind of an advanced thing in the Swift. Okay, and it has lots of different usage here, but here we're just gonna focus on the guard let thing. Okay, if you want to know more about guard, you can take a look at the official documents. It has lots of usage here. Okay, useful. Well, it can be really handy in some case. And in this case, when we say guard let, okay, if the greeting you passed in is a nil. Okay, it doesn't contain any useful information. You're gonna fall back to this else branch. Okay, it's kind of similar behavior. However, when you use a guard, okay, in the else statement, you have to explicit return. Essentially, you say like when you apply guard let, and something something bad happened. In this case, the greeting is a nil. Okay, you're just gonna terminate this process. Just return something. Okay, this is how you use guard. Okay, and if there's some valid data contained in the optional greeting variable, you just gonna assign to this one, and in the rest of this code, this greeting, this string greeting, okay, gonna be available throughout the entire scope of this function. So you can use this thing here, okay. So it's two different styles to unwrap a value by using the optional binding. Okay. Now there are some general guidelines to help you choose between the if let and the guard let. Okay. So Swift doesn't require else clause in the if let, but an else clause is required in guard let. Okay. So you can say if let something, but you can just get rid of the else one. Okay. But if you want to use guard let, you have to be explicit about the behavior inside this else branch, because you have to terminate this. You have to terminate the code execution. Okay, you have to return something, or just say return, which means well, just jump out of the scope. Okay, and yeah, this is the second point I mentioned, and also if let. So it's kind of design, or it's kind of design philosophy behind this if let and guard let. So if let makes us focus on the correct path, which means, well, if there are some valid data, okay, let us to focus on that path. So how are we to deal with if there are actually some valid data inside this optional, okay? And guard let actually lets us focus on the error path, okay? So if, when we use guard let, if there is some, well, there are nothing inside this optional, so how we handle the error. Okay. Now let's go to the next one. It's called optional chaining. Okay. So again, we have a greeting here, and this time we assign some value. Well, it's hello, and this optional string. Okay. So what if we want to have another variable which named as noun of characters to count the character inside this string? So we can call the .count, which is kind of a function already defined in all string or in all collection. Okay, it can count the character inside any string. Okay, so do you think there's any trouble here? There's any problem here by doing that? Yep.
Well, the count may not exist if it's a nil.
Yeah. So what if the greeting actually is a nil? Okay, it doesn't have a count anymore, right? So you're gonna give you some warning, and we can fix that by doing something like that. Okay, well, we can again do a if let. Just to mention, do you still recall this syntax here? This called closure initializer. Okay, essentially just run some code and use some data returned from that code to assign to the variable, which in this case is the noun of characters. Okay. Inside this code block, we just use a if let. Okay, we just use a if let. And in this branch, if the greeting has a valid data inside that, we just return the count. Else, we're just gonna return nil. Okay. So in this case, the noun of characters is essentially a optional integer. Okay, it's not an integer, it's an optional integer. Okay, but thing is, it's too verbose. Okay, it's too much code, too many typing here, and we can utilize the optional chaining syntax here. Okay, so we can just see the greeting with a question mark and say .count. Okay, in this case, if the greeting has some valid data, you're gonna call the count. The count function, well, it's actually a variable. Count property on the greeting, okay? If not, you're just gonna return null. Sorry, you return nil. Okay. So if the greeting is nil, just gonna return nil. If the greeting is not nil, it has some data inside that, you're gonna call the count. Okay. And well, you got basically exactly the same behavior than the previous one, the previous approach. Okay. Now we can also use the optional chaining on functions. Okay. So I define a function named as runFunc here, and it takes a function and just run that function. Okay. And you can see here, well, this thing, well, I say equals nil is providing a default parameter. Okay. And this my func, this argument take, the type is, well, it's an optional. Okay, it's optional wrapping around another function. That another function type is a function that takes nothing and returns nothing. Okay, and in this case, I can just call that function. I just call the runFunc. Okay, and I can print something which is the function I passed into this this runFunc function. Okay, and inside this runFunc, I just call that function, just run that function. Okay, so in this case, I just print something. It's a total valid. So what if I pass something like I pass a nil into that? Okay, just say runFunc with a nil. Okay, so you will go into this scope, and you're gonna use this question mark. So if the function you passed in is a nil, okay, just do nothing. Just do nothing. Okay, if it's valid function, you're gonna run the function. Okay, that's how you use the optional chaining of functions. Now, let's take a look at another thing here. So before we get a none of characters as a type of optional integer. So what if we just want to get an int? Okay, we want to do special like error handling. Let's say if it's nil, I just want a 0. Okay, don't give. If the greeting is nil, just give me a 0. Okay, I don't want a optional integer. I just want an integer. Okay. So how we deal with that? Well, again, you can try something with if let again. Of course, you can also try with guard let, whatever you want. And in this case, I just say if, well, the greeting is not a nil. Okay, just return the count. If it's a nil, I'm gonna return a 0. Okay. But well, again, too many typing. Okay. So let's take a look at this thing. It's called nil coalescing operator. Okay, it's followed by 2 question mark. Okay, so if the greetings here is a none, okay, this statement just gonna return none. Sorry, return nil. Okay, and then when it returns nil, you're gonna use this default value here. Okay, this is how you use the nil coalescing operator. Well, if it's not nil, you just return the count. Okay, and the type of this none of characters variable this time is an integer. Okay. Any question here? Okay. And also, you can chain the nil coalescing operator. Okay. So in this case, for example, we made the name variable again a optional. Okay. So in this case, I can say, well, if the greetings has something, okay, I'm gonna just use the count of number of characters inside this greeting string. Otherwise, I'm gonna try to see, well, whether I can get the number of character inside this name string. Well, if both things are nil, I'm gonna use the default one, just use the 0. Okay, so you can chain the nil coalescing operator. Okay. Now, let's take a look at another thing. It's called unconditional unwrapping. Well, usually we also call that as force unwrapping. Okay. So again, we have the greeting variable here. It's optional. And what if, in this case, you can be 100% confident that the greeting will never be nil? Well, even though the type is declared as nil, as an optional, but I know never gonna be nil. Okay, it always have something. Okay? In this case, you can do something like that. Okay? You can see, well, greeting with exclamation mark. Just force unwrapping this thing. Okay? Just say, I don't care like whether actually there's something inside that. I'm just gonna use the data. Okay? In this case, if the greeting is a nil during the runtime, it's just gonna throw some exception and crash your app. Okay? And there are some important things to mention is the unconditional unwrapping or the forced unwrapping is, well, really dangerous. Okay? And it's not recommended at all. And most of the time, you cannot be really 100% sure about that, the situation that, the assumption that some optional variable always has data. Well, it's marked as optional. Maybe in some case it can be nil. Okay. And forced unwrapping is not allowed in any assignments. Okay. Well, unless it appears in the skeleton code. Okay. Yep.
I'm just wondering why it even exists in Swift if it's so dangerous.
Well, I mean, it's dangerous, but you still have some cases where you can see, you can assure some data actually exists. So for example, I create a array of data, okay, kind of hard code array of data, okay, and I say, and I know that array has, well, the length is not 0. It has some elements, and you can call some function that's say, well, random elements. It's a kind of function defined in standard library. Essentially, just grab a random data from an array. Okay. In this case, well, when you hardcode something inside that, you can ensure that you always get some elements. However, the signature in the standard library for define that function named as random elements returns some optional. But in this case, you can be 100% sure I always have some data because I hardcode that one. Okay? So still there are some cases you might find this forced unwrapping helpful. Okay? But like in usual case, you don't use that. Okay? Now let's take a look at error handling. So just jump to the throw exception. How we're supposed to throw exception. So first thing you need to notice is if you want to throw some exception in some function, the first thing you have to do is mark the signature of the function with a throws keyword. Okay? It's after the parentheses of the parameters. Okay? But before the return type. Okay? You mark it as throws. So for example, if I want to throw something in the first function, which named as, well, throw arrows, I'm going to mark that as throws. And in the second function, which I can ensure I don't throw anything inside that, so I can just declare this function as usual. Okay? Now let's take a look at how we actually throw something inside the function body. So again, I expand two functions I showed before. In the first one, we're gonna throw something. I use let. Say, well, if I want to unwrap a value, which is an argument passed in. So if the value is nil, okay, I'm gonna throw some arrow. Okay, so you use the throw keyword. Okay, here the throw keyword. Okay, and then followed by something called a nest arrow. Just throw some generic arrow here. Okay, so a nest arrow is something defined in standard library. And it's just some generic arrow here. Okay, and in the second one, we just don't throw anything. Well, just return something. Okay, so if you want throw, use the throw keyword and mark the signature with throws. Okay, now how about define your own arrow type? Okay, we're gonna see one protocol named as arrow. Okay, so as long as your data structure conforms to arrow, it can be throw. Okay, so in this case, well, you see before we throw some generic arrow as a nest arrow. Okay, so what if I want to define my own arrow type? In this case, I have an enum, well, named as unwrap arrow, and the type is, well, I conform that enum to an arrow protocol, and I have a case which has, well, it's a simple case, just no value, say. Okay. Now I can throw that, well, customized arrow here. Just say throw unwrap arrow dot no value. Okay. Now we can throw arrows, but how we supposed to actually catch the arrow and handle the arrow? Okay. So let's see something called do try catch block. Okay. So the where throw arrows, this function gonna throw something. Well, we already know that you're gonna throw something. Okay. And when we trying to run that thing, run that function, run the function that will throw, we're gonna mark that as try. Okay, you're gonna say try to run this thing. Okay, and wrap all the try statements inside this do block. Okay, so we're gonna do something and let's try something. Okay, and if something happens, if some error, some exception is thrown, okay, we're gonna fall back to the catch statement. Okay, in this case, I can specify the type of error I want to catch. So I want to say if I just want to explicitly to catch the unwrap arrow dot no value. Okay, or I want to catch that arrow, you can fall back to this branch. Okay, but in this case, the 3 gonna be printed out. So what if I just pass a nil into that? In this case, you're gonna throw something. Okay, so we're gonna get the no value to unwrap. Okay, to be printed out. Okay. Now there's one more thing to talk about is optional try. Okay, why we call the optional try? Okay, the syntax is try with a question mark followed by the try keyword. Okay, and when you use this syntax, and the where throw arrows, the function actually throw something. Okay, it's just gonna give you a nil. Just gonna return a optional. Okay, it doesn't crash your app. It doesn't throw any exception. Just return nil if the function followed by the try question mark thing throw something, just gonna give you a nil. Okay, it returns the optional. Okay, now the next thing is force try. Essentially, it's kind of approach to disable error propagation. Okay, so when you just say try something, okay, and some exception is thrown out, it's gonna be passed to the parent caller. Okay. However, you can disable that behavior. Just use the try with an exclamation mark here. Okay. In this case, when some exception is thrown inside this well throw arrows function, it's just gonna crash your app again. Okay. Is that clear? All right. Now we can just stop right here. And I think that's the last topic. It's about rethrow. It's a kind of not keyword. But anyway, we're gonna continue that. Yeah.
Is the only option for an error to crash the app pretty much?
What do you mean by the only
I mean,
option?
like if it was a computer program, you could just print a message to the terminal, but it is the only like realistic thing to just close the app in an iOS app if you catch it like a significant error.
I mean, so you do want to intentionally crash your app or not?
I don't know. I'm just
Okay. So yeah. So let me think about that. So if you want to use the force try, usually you can be 100% sure about this thing actually don't throw anything. Okay. And if you actually throw something, it should be something really, really like fatal. Okay. In this case, it can help you to catch the bugs. Okay. So if you want to see, like, I want to try something, and if you can actually throw in some really, really important cases where you can like 100% sure that your program actually goes wrong, you can use force try. Okay. Because at that time, your app is crashed by this line. You can see, okay, definitely there's something wrong with my app. Okay. Let's usually use the force try. I mean, well, of course you can just try, use the do try catch block to catch the error and print something to the console if you want. Yeah.
So what if it would just throw an error without the try?
What do you mean by throw the arrow without try? Oh, you mean just call the yeah, maybe just get rid of this try, right?
Yeah.
Just call the well throw arrows, right?
Yeah.
Okay, that's
But in the last one, the previous slide.
first one. Okay. Which one?
Yeah, this one.
This one.
Yeah. Forced try, without forced try.
So just get rid of this try exclamation mark, right? Just say well throw, right?
It's kind of the same.
Oh, it's not the thing because it won't let you compile.
Ah.
Yeah. So compiler actually gonna enforce you to do some error handling. So you want you to be explicit about the behavior when some exception happens.
So that's not helpful, yeah.
Mm-hmm.
That doesn't catch it, so it's not helpful.
So if you just say just call the function.
Just go with the forced try. It doesn't do anything helpful.
Well, if you throw, it just crash your app.
Yeah.
I mean, yeah, as I mentioned before, in some special situation, you can use that to catch some fatal bugs in your app. But yeah. So all these techniques here basically just let you to be explicit about the behavior when you see some errors, when you see some exceptions. Okay. So if you personally just want to crash your app, well, you can do with the first try. Okay, you can do that way. Just different behavior, different techniques, different tools that let you to make your choice when you actually, handle the errors.